Hello, this is Jeffrey. Today we'll be discussing about vectors. The first thing we'll discuss here is the dot product between two vectors. So we see that given two vectors, v1 having x1, y1 and z2, and vector v2 having s2, y2 and z2. How to find the dot product between these two vectors? So the dot product between vector v1 and vector v2 can be achieved by multiplying all the elements respectively. That is, we will multiply s1 with s2 and y1 with y2 and z1 with z2. So it therefore means that v1 dot v2, which is the dot product between v1 and v2, is therefore equal to x1 dot x2 plus y1 dot y2 plus z1 dot z2. That is given if the element of the vector w is 1, 0, 0 and the vector v is 0, 1, 0. Then if we do the dot product between vector w and v is by saying 1 times 0 plus 0 times 1 plus 0 times 0, which is therefore equal to 1 times 0 plus 0 times 1, 0 times 0, everything will give us 0. So the second thing here is to find the cross product of two vectors. So also if we are given vector v1 and vector v2, if we want to find the cross product, then we need to put them in Cartesian coordinate system. That is, we will represent it using ijk. This is just like a matrix form. So we will represent it with ijk. So the cross between v1 and v2 is this. So we see that the vector v1 is the first one that is represented on the first, and vector v2 will represent it on the second row. So the vector v1 is represented on the first row, vector v2 on the second row. Then the cross product, therefore, is we will achieve it by multiplying v1 with z1 and z1 with y2. That is, first you say this times this, that's y1 times z2 minus z1 times y2. So what in essence is what I'm saying is, we first of all say this I is like you are using I to expand the product of y1 times z2 minus z1 times y2. So that is it. And then the second is minus. So the first expression here you do is positive. This is minus, this is positive. So it's by saying that I has a positive sign, J has a minus sign, and K has a positive sign. So that is why the expression begins by saying that this I is positive, the J is negative, and the K is also positive. So to find for J is J therefore is x1 times z2 minus z1 times y2. So if I make an expression for J, it's like deleting the row horizontally and vertically. If you delete this row, if you delete the horizontal row and the vertical column, then we will be having just z1 and y1. I mean z1 and s1. And x1 and z2. So I just say z1 times s2 minus z2 times x1. So the third will now becomes, if I still delete this row and the column consisting the column of k and the row of the column of k and the row of k. If I try to, it seems, if I assume it is deleted, then I will be having what, x1 y2 and y1 x2. So if I take a crossing, the cross between x1 and y2, that's x1 times y2, will give me what, x1 y2, y1 times x2 will give me y1 x2. So I will just say x1 times y2 minus y1 times x2. Then I will now use k to multiply the contents. So it's quite very easy. To explain it better for more understanding, first you begin by starting with I, and assume that I is positive, this is plus, minus, plus, and assume that I is positive, J is negative, and K is positive. It's always like that. It is assumed that in the matrix, all the member elements are plus, minus, plus, minus, plus, minus, plus, minus, plus. So if you actually want to read out the signs are. So if we do like that, then if we delete the column and the row of I, you will have y1 z2 z1 y2. So you just cross multiply that y1 times z2, and then z1 times y2. So if you take the difference between the cross multiplication, so that's how we got this. So I told you that the j becomes negative. Then if you delete the row and cross multiply and take the difference between the cross multiplication, you get this. It's also the same thing with k. So if you see that given these vectors, I 1 1 1 and 2 1 1, then if we try to do the dot product of these vectors, so if here is 1 1 1 and here is 2 1 1, so the dot product between them, so you see that here is 1 1 1 and this other is 2 1 1. So the dot product between them will just be I into 1 times 1 minus 1 times 1. So that's how we got 1 times 1. Then the second one is j into, if you delete this row horizontally and vertically, so you see that we now have 1 times 1, then minus 1 times 2. So that's how we got this 1 times 1 minus 1 times 2. J is okay, it becomes minus j. So plus k. So if I delete the row horizontally and vertically, then it becomes 1 times 1 times 1 times 1 times 2. So that's 1 times 1 minus 1 times 2. That's how we got this. So if you do everything, so it becomes 1 times 1 minus 1, which is 0. That's how we got 0. 1 minus 2 and minus 1 times this, it becomes plus. So plus 1 minus 1, this is now minus. So if I put it in vectors form, it becomes 0 1 minus 1. So how we can compute the angle between two vectors? The angle between two vectors is given by cos theta, which is the dot product between the two vectors divided by the modulus of the first vector and the modulus of the second vector. So we know that the modulus of a vector, or the positive magnitude of the vector, is by saying the square of all the contents, the root of the square of the content. That is, the vector from above, in our vector, we have vector for vector v1, we have x1, y1, and z1. So if we take the square of all the content and the root of the resulting answer, that is the modulus. For vector v2, we have the content x2, y2, and z2. Then if you take the square of all the content and you sum everything and the root, the sum of the square of all the content, then the root of the resulting answer will give you the modulus of the vector. So the modulus of this vector v1 is arrow2 and vector v2 is vector v2 is, the modulus of vector v1 is root 3 and vector v2 is root 6. So the dot product between the two vectors we already have, which is 4. I think it should be 4. Let's see. The dot product between the two vectors. Yes, okay. The dot product between vector v1 and vector v2, if we express it, it is 4. That is 1 times 2 is 2, plus 1 times 1 is 1, plus 1 times 1, that is 4. So, and it becomes cos theta is 4 over root 3 dot root 3. So you having 2 root 3 divided by 3, because this is root 3 times root 6, which should give us root 18. Or better still, if you rationalize, you multiply the top and bottom by root 6. Okay, for this problem to express it, you know this is 4 divided by root 3 dot root 6. So you know that root 6 is the same thing as root 2 times root 3. So root 3 times root 3 will give us 3. Then the root 2, if you rationalize, that's root 2 times root 2. You have 2 root 2 divided by root 3. So for better understanding, I was saying that root 6 is root 3 times root 3. So the root 3 times root 3 will give us 3. We'll be having root 2 left. So it's now left with 4 divided by root 2. So you rationalize that as you multiply the top and bottom by root 2, it becomes 4 root 2 divided by 2. So that's now 4 root 2 divided by 3 root 2. So yes, 4 root 2 divided by, so that is, this is 4 divided by root 3 dot root 6. So which is the same thing as saying root 3 dot root 3 dot root 2. So root 3 times root 3 will give us 3. Then we are having root 2. So if you rationalize the sort, it becomes 4 root 2 divided by 3 root 2. 4 root 2 divided by 3 times 2. So 4 root 2 divided by 3 times 2 becomes 2 root 2 divided by 6. So for better, okay, I have decided to make this more simpler to understand. So 4 divided by root 3 dot root 6, which is the same thing as 4 divided by root 3 dot this is dot. I think it contains 2 dots there. So this is 4 divided by root 3 dot root 3 dot root 2. So it becomes 4 divided by, root 3 times root 3 is root 3. Becomes 4 divided by 3 root 2. So if you rationalize this sort, it becomes 2 root 2 divided by 3. So we'll multiply the top and bottom by the root of 2. So root 2 times root 2 is 2. 2 divided by 4 will get 2. So that's that. So the angle between two vectors, the two vectors v1 and v2 becomes 2 root 2 divided by 3. So the fourth of the problem is to compute a scalar projection. The scalar projection of a vector v1 onto vector v2 is the number proved